You might notice that the camera is not shaking around. I managed to build myself a little camera mount to hold my camera while I'm working. And so hopefully that will improve the video quality a little bit. I'm also going to try to do some stop motion-y kind of work today while we're working to capture some of the stuff that we haven't been showing you guys because we haven't had a tripod mount for this thing yet. Maybe in a future video I might even show you how I built this cheap camera mount for about $5. So, but anyway, for now, Mike and I are down here at the shed. We're going to get busy. We're going to start where we left off last week by installing the fuses on the 50 volt AC and 5 volt DC, bringing that power back up to the back box. I want to show you something. I did a little design change, and I'm going to point that out. That's one of the first things we're going to be working on. It's along with this power stuff. So let me flip the camera around to the front and point at the back box there, and then I'll show you what's going on. So here we are looking in the back of the back box, and you can see the DC 50 volts, or I'm sorry, 70 volt DC power supply. If you look at these two terminal blocks, and that's the 70 volt DC terminal blocks, there's actually only one connection that comes off of that, and that's these 70 volt relays up here. So these two wires connect to those two wires, and that's it. There is no other anything that's ever going to get connected to that 70 volt supply. So I decided that's a total waste of these big terminal strips. I'm going to take these terminal strips back off. I'm going to put a connector on here instead of a terminal strip, and I'm going to reallocate these terminal strips as 5 volt DC distribution. I'm not exactly sure where I'm going to put that. I might mount them down here somewhere because the other board sits, you can't hardly see it, but right up in this area here is where the main board sits, and there really isn't any room there, and I don't really want to take the DC all the way up from here and run it all the way up like up to here to post. It would just be too far. So I think mounting it down here is probably the best thing we could do. And then I can take that, the 5 volt DC is going to have to be distributed to all the lights, to the sound cards that are going to be installed here, and maybe other things in the future. So having a distribution point down here where we can distribute that 5 volts, I think will make it a lot easier. So I'm going to get started. I'm going to move the camera back a little bit, set up the stop motion so you can watch me work, and I'm going to go ahead and take this off, hook up the connector, and get this section all wired up here. Okay, I thought I had recorded some hyperlapse video, but apparently it didn't record anything. So I don't have anything to show for us doing this connection change, but there really wasn't all that much to see. We took off the two terminal blocks by unscrewing it. We crimped some connectors onto these wires, connected them together. That's all. One thing that's a little unique about this connector, and I'll show you, is that because we use another 3-pin connector somewhere else in this board, I hooked this up with 2 females and 1 male in here, and the reverse of that on the other side, so it can't accidentally be plugged into the other one. We don't use that middle connector, but it's just going to act like a key. So anyway, we'll try to get the hyperlapse working while we're working on installing the fuses. Okay, we're getting ready to film here in the back box. I have these 2 fuses. One is going to connect to the plus on the 5 volt side. One is going to connect to the 50 volt AC side. Then we're going to connect wires to the other side and just shrink tube onto them, and then take them up into the back box, and we're going to take the 2 grounds up into the back box, and then we'll move around back there to do the rest of the work. So again, I'm going to try a stop motion while we're doing this so you can see what we're doing. So the camera is still pointing down into the pinball machine, and I'm just standing here in the back. If you could see that, you could tell that I'm having great difficulty soldering this wire on. There is such a massive amount of metal here that the soldering gun just will not quite heat it up. So what I'm about to do is get a second soldering iron and apply 2 soldering irons at once to this so that there's enough heat to heat it up. I'm not sure how well you'll be able to see us working in here because there's going to be a lot of hands and arms in the way, but I'm going to run it. If you can tell, you can tell. If not, that's what we're doing. Okay, we've finished up that wiring. As you saw, we had to use 2 soldering irons to heat up these lugs because there's just so much mass of metal here. But we have good strong contacts now. We've secured everything down, put lugs on the wires. The white wire running up to the back is the 5 volt. The brown wire is the 50 volt AC. And now we'll move around to the back of the box and wire these into the terminal strips on the back. Okay, I'm getting ready to set these terminal blocks up here. I'm going to pull a couple of these score wheels out to give myself a little more room to work here while it's easy to do this. And then I'm just going to screw these terminal blocks in. Okay, so we're going to take the 5 volts and bring them out to this block and distribute it onto here. We're going to take the 50 volts and bring it up to this block and distribute it onto here. And then I'll run that in fast forward so you guys can watch that very quickly. Then I'm going to disconnect this. I'll do that right now because I don't want that plugged in when I start hooking up the voltage and testing it out. So anyway, we'll plug the thing in, we'll meter all of our voltages to make sure they're good, and then we'll start plugging stuff in and start testing and wiring and stuff like that. Okay, we've got the terminal blocks installed. This is the 5 volt plus and ground, 50 volts AC coming in here, and this should be outputting 70 volts DC. So what we're going to do now is power this thing on, take some voltage measurements and stuff, and make sure we're getting power to where we think we should be getting it, and that it's reading approximately what it ought to read. Before we actually connect that up, I am going to disconnect this wire just to make sure that we have only 50 volts AC here and not a whole lot more before I hook it up to the rectifier and make DC out of it. So we'll bring you back in a second once we get the power cords and stuff sorted out. Okay, I've got you guys handheld for a second. You can see we have the power cord coming out here, plugged in there. And up here in front, oops, I tripped over the cord, sorry about that. Up here in the front, we've got this all wired up. I'm going to reach underneath and turn that power switch on. Power switch has come on. You can see the 5-volt light is on. We can hear the transformer humming. You probably can't. But we'll take you back up, set you up in the back, and then we'll get the meters out and meter everything. Okay, I got my meter out. Unfortunately, it has an annoying habit of beeping whenever it's around 60 volts or 60 hertz to warn you that you might get electrocuted, so I'm being warned. I have the meter set. I don't know if you can see that in here or not, but it's set on AC. Actually, it's right down there. It's set on AC auto ranging. So I'm going to go across here. And I'm reading 57 volts AC. So that is perfectly fine within the range of what we're looking for. So now I'm going to go ahead and change the function back to volts DC. And I'm going to come across this. And with the red probe here and the black one there, I am reading plus 5 volts DC. So that also looks perfect. So give me a second to wire the wire back on. Mike, would you go turn it off? Okay, we have no more AC. That's a good thing. We'll probably put terminal lugs on these. We haven't done that yet, but for right now, it's good enough just to plug this directly in. Okay, Mike, if you would turn it back on. Now again, this ought to read about 70 volts DC. I'm going to try and grab, let's see, where is the ground wire coming from? The ground wire is coming from there, and the hot wire is coming from up here. And I'm reading 78 volts DC, more than adequate. So it looks like we have successfully reaccomplished our power systems. We'll finish hooking things up and we'll start playing around with this. Okay, just to show you what we're about to do, this is the 5-volt terminals that we just hooked up. We're going to run wire from there up to here and screw it into this 5-volt distribution block for this processor. We've made up a pre-made up wire wrap a twisted pair wire set to distribute this up to the top. And so I'm just going to put this into the terminal block.
You put it in there so they cut around it, right? So you don't have to cut the whole way. Okay. Okay.
And I'm going to have to run and get a little tiny screwdriver to fit that. I'll be back in a minute.
I'll just let him leave a message, and if there's something significant, I'll call him back. If it's a reiteration of something we already talked about, I just ignore it.
Well, it appears that I'm wiring this up live. I probably should have turned that power off before I did that. But there you go. Our processor is running on our internal voltage, internal units. Pulled out from somewhere. So let me pull out some of these wires because I don't need these right now. I have a test program loaded in this unit right now. Let me make sure you can see over here. Tell you what, I'm going to try and bring you in closer. Hold on. Okay, I want to quickly show you what I've got here. So there's a test program running in here that maps these input switches one for one to the output relay, so I can just activate them at will, and I roughly know which one I need to touch. And there's two different sets of codes in here. So these two banks of switches will activate a relay. Like I'm going to activate this one right here. So when I'm going to activate this one right here. so when I touch that down, it comes on. When I let it up, it goes off. These two banks of switches turn on the exact same relays, but they'll just pulse it once and then let it go. So if I touch that, it pulses, and even though I'm still holding it, it's off. So if I touch it again, it pulses and goes away. So that way I can, for solenoids that only need to be pulsed, I can hit them over here. For ones like flippers that I want to hold down for a while, I can hit them over here. So that's what we're going to do. And let's see, let me swing the camera over a little bit. I don't know if you can see them from here, but the DC solenoids are over there, and the bottom side of this bank will activate those. You can kind of see the lights turning on over there. So they're there. It's a bad angle, but believe me, they're working. So what we're going to do now is reinstall the play field, pull the wires from the play field back up to the back, and then we're going to start wiring in the DC solenoids first, and then we'll wire in the AC solenoids. So the DC solenoids will connect to this connector right here, and the AC solenoids connect to a combination of this connector and this connector. This connector goes underneath into the back box to do the chimes and door lock, and this one does the play field. So right now we're going to be wiring up J1 and J3. So we'll probably move the camera back a little bit, put on the time lapse, and show you guys as we're going through. It's a lot of wire crimping, hooking up, and then I'll bring you back when we're ready to start testing. So in my haste to wire, I did make a mistake that I need to correct. These two wires are inverted. This top wire is plus 70 volts. That should be the brown wire. The green wire is the ground wire. So I need to pull this connector apart and flip those wires around before we actually start turning on these relays and providing current out to the table. So I will do that right now. I'm not going to film it though. Okay, I flipped those wires around. Actually, I replaced the connector. I just cut it off, and because it was easier, I don't have the tool to remove the pins. But I've connected up the brown wire, so the positive comes up here. It's fed into the top of these relays. When you energize this relay, it'll provide that power to the output connector. Right now we have one of those outputs connected, which we believe is the left pop bumper, and then that should come back through this ground wire, which takes you back to here, completes the circuit to here, and that energizes that. So Mike, if you would turn the power on, I'll look for smoke. Okay, no smoke. So we will start tapping around on units until pop bumpers pop. I'm going to go with the pulsing ones.
the left one.
And it seems to be pulsing just fine. Is it pulsing all the way down?
It's
And
full stroke. Yep.
good.
It actually seems like just about the right length of time.
Yeah. Well, in reality, I think I'm going to program it so that it's down as long as there's a ball on the thing. Although I might put a backup like twice as long as that, and then it'll turn off if the thing doesn't leave the connector.
Well, if it just fully engages, the ball has to come off of it.
Okay, just a conversation for the camera here. These 5 solenoids are DC solenoids, and to keep back EMF from destroying the relays, there's a little diode across each of the coils. One of our solenoids, the right slingshot, does not have a diode on it, so we're going to wire up all but that slingshot, and then we're going to bring you back for testing. So I'm going to take you back into high-speed mode while I wire up all the rest of the wires and get them connected up.
All right, power off.
Okay, we've got the rest of those solenoids hooked up, everything but that one without the diode on it. So we're going to go ahead and start stepping through here and clicking on them.
Which one are you clicking? That's the left swing.
Left swing.
That's the center or number 3.
That's 3 at the center.
That's right.
That all looks like it works great. Okay, so we're done with that. We'll move over to wiring up the AC solenoids that go to J1 up here. There's quite a few more of those. So we'll start wiring it up and then we'll bring you back. Okay, we're getting ready to wire up the AC solenoids. We've dressed the wire down across the bottom and up to here. The AC solenoids on the play field hook up to J2. The AC solenoids here in the back box is going to hook up to J1 eventually. So I'm starting off just like I did before by hooking up the 2 ground wires, and we'll pick one of these other solenoids and hook it up, and then we'll bring you back and start testing. So I'll move you fast forward until then. Okay, we've made a connector and hooked up our 50 volts AC up to these relays, so they now have power to actually power the units down below. So now when we touch this thing, it should actually fire. Oops, not that one.
That's it.
Did it reset it?
It did, but it's holding it in.
Oh, it shouldn't be. Oh, that might be gravity. That's probably gravity that's not.
Hit it again.
Okay. Let me hit the pulse one. Did that? Is that it?
Yeah, that's it. Okay. It just, I guess you need a little weight or something.
Yeah, you probably need to just set the playfield down,
And it'll,
and the weight of it'll do the dropping. You want to try it?
I wonder if there's a spring there. I'm not. No,
You're not worried about it?
I'm not worried
Okay.
about it. We know that it should work, and if it doesn't, we know how to fix it.
Okay, so it fired the solenoid. So next step is just like before, we'll go in and wire up all the rest of the connectors. So we'll put you back into high-speed mode.